Well, if I can make it go. Okay, let's talk just for a few minutes about networking. Again, you've had networking classes. You've had a router's class. So this should be hopefully a review, and I've taken a number of the slides out. We'll go through it quickly again. Identify the basic components of a network. They've got a couple of different kind of definitions that they use about how a network is and how it works. Describe the features of IPv4 and IPv6. IPv4, been there, done that. There are subnetting problems that count as homework problems to do that. Configure clients for IPv4 and IPv6. They have a lab to do IPv6. I don't think I asked you to do IPv6, but you can do it in the GUI just to see how it works. Good thing to do. But for the core server, I want you to get an IPv4 address on it. Upgrade a network from 4 to 6. We talked about that in Cisco, a number of ways to do that, the dual stack, the NAT, tunneling, different ways to make them both work. And I think that what really happens on most of these machines is they're running a dual stack, aren't they? These machines have IPv6, and IPv6 gets installed by default on Windows 7 and the Server 2008 machines. And I think he has a lab to disable IPv6. I don't ask you to do that. Don't disable IPv6, not hurting anything. There are even some processes that use IPv6 even though you're communicating with the version 4 system. Troubleshoot TCP. I didn't ask you to do any of those things, but take a look and know the Microsoft specifics. The one that they really love, because they invented it, is Pathping. Pathping is kind of like a combination of ping and traceroute. It takes longer to perform, and you should just do one just to see what it does. It takes longer to perform, but it does more analysis for you. It does take, it's like, and when I do it, it's like, are you ever going to finish? Because I'm impatient. It will. And it gives you a little bit more information than either of the other two will by themselves. Basics of networking, a group of 2 or more nodes is a practice of designing, implementing, managing a collection of computers. There's a number of different ways to design networks. Networking in its most basic sense is sharing of information. It doesn't have to be electronic because you guys network all the time. I mean, I know you social network. That's why we had to block Facebook, right? Social networking, sharing information. We're more concerned with digital networking where we share information maybe amongst each other. Sometimes we want to do that, sometimes we don't want to do that. I'll call back, hopefully, to your memory the great access cheating scandal that we had years ago. In that case, we didn't want them to be able to share information. There are lots of cases where you do want users to be able to share information. If you're working on a group project, you might want to have a document in the center that everybody could access and make changes to. So different kinds of sharing. One of the things that we want to, not specifically in infrastructure, but one of the things that we want to be able to do is to control that sharing, how much sharing can take place, what goes on. But designing and implementing what kind of a network are we going to have? And a lot of this, after you learn about the different devices, is just a matter of how we're going to connect this thing together. What can we do? What kind of hardware are we going to buy? Server can be used to do a lot of things. A server can be a router. Is it a good router? No. But will it route? Yeah. Do a number of things that it's not necessarily designed to do. Lots of infrastructure capability. So the types of networks that they talk about here, and I got slides on each of them, are network scale, connectivity methodology, network architecture, topology, and protocol. And some of these, just by looking at the terms, say, oh yeah, I know what that is. Network protocol. Is it a network or is it a TCP IP network? What protocol are we using? Network topology. Is it a ring or a bus? Or is it a switched network? The network architecture. So each of these things, basic networking without internet access, because we don't have a router in here, we're just sharing information within our own little world. This is relatively secure, is it not? Because there's no real method, unless one of these are bad guys on your client computers, to really attack the network. So it becomes relatively secure here. Then when we're going to add internet connectivity, we have to add a router, the gateway that allows the information to go from our private network to the public network, and we're going to have to use, and they show here, public IP address, private IP address, some form of NAT or PAT, network address translation or port address translation. Again, you can do all this with a server, with routing a remote access server if you want to. And from your virtual machines, that's in fact what happens. There's a 2003 server that's set up as a router that does PAT because it has a single IP address that it uses on the other, the quote public, which is the 1060 network, which is still a private address, but then it gets natted. So we got a number of natting things, nats, that happen for you to get from your virtual computer onto the internet. Local area, smaller geographic, and you look at these. The metropolitan area network, 2 or more LANs, but do not extend beyond the boundaries of an intermediate town, city, or metropolitan area. That, to me, that's kind of a nebulous sort of definition. And then a wide area network, relatively broad geographic area. I, as you know, kind of prefer the layer 2, right? Where are the differences between LANs and WANs? Layer 2. What kind of protocols are we using? These are kind of neat, but can we have a wide area network inside this room? Using WAN protocols? Sure. What we can do with a WAN, generally go further. And when you look at these things, local area network is high speed. Gigabit, 10 gigabit, probably 100 gigabit pretty soon, but doesn't really go all that far. Wide area networks go longer distances, but tend to be slower speeds. And I think just generally that happens. So network scale, how networks occupy geographic space, most common LANs and WANs in these things. Connection methodology, the type of hardware used to connect the nodes. Topology, based on the physical and logical relationships. And as you know from Networking 1, the physical topology and the logical topology can be different. We can have a physical star and a logical bus. If you remember, we plugged everything into a hub is what we would have in that case. The network topology, communicate with how they communicate with each other. Is it a TCP IP network? Is it a netware network? What protocols are we using to connect these things together? The basic components, you already know all of these, I think. NICs, repeater. Repeater renews the signal. And digital is kind of handy for that because it's digital. It's either on or it's off. Unlike a logarithmic signal, you'd have trouble renewing the signal, stripping all the noise off. You can do that. Hubs. Hubs are still around. There are still instances when you would want a hub, and I think mostly in the security world when you actually want to see all of the traffic, you may want a hub in order to do that. Because when we put it on the switch, we only see the broadcast traffic and the traffic to us, unless we become a man in the middle. Bandwidth, network bridges, network segments, bridges and switches. Bridges and switches, similar sort of devices. A bridge normally not going to have as many ports as a switch. A bridge, bridges in software, a switch, switches in hardware. So generally a switch is going to be faster. A switch can be used as a bridge. Both of them do layer 2 separation, collision domains. Routers connect networks together, connect networks, subnetted networks or networks with distinct subnet masks that put them on separate network addresses. And there are, as you saw in routers, some things that you can do to make your life easier or more difficult when you do these things. Nice pictures there, right? IPv4, IPv4, 32-bit, right? Subnet mask and all that good stuff. IPv6 has a subnet mask too, but you don't write it as the 255.255.252. You use the / the CIDR notation in order to do those things. TCP, the layer 4 protocol. TCP is connection-oriented. UDP, connectionless, whether we want to have acknowledgments of what's going on. Guarantees the delivery of the packets. Guarantees because what it does is acknowledge that the packets actually got there. Physical layer, I'm just going to go through these because I think that you probably, hopefully, at least got a more extensive look at the OSI model in the networking classes. These are just the generals and general what goes on at each of those layers. Anatomy of an IPv4 address, addressing scheme of 32-bit, 4-byte address, binary numbers, zeros or ones. And the most we can have is 255. And 255 represents how many addresses? $250 what? 3. You're going for usable addresses, right? Remember, when you go through these things, 0 represents something that's real. 0 to 254, or 1 to 254, 0 is not going to be usable. The all zeros and the all ones address is not going to be usable. Octets, the decimal points are actually for our use. The computer really doesn't have to have that. It just reads the zeros and the ones. And the digital is for our use. And I think I know I do. On the if you have trouble with the conversions, I've got a conversion sheet on the Moodle page. So that goes through the converting the binary to decimal. There's also a link to the spreadsheet that you can use to do these things with. I'm not interested in getting hung up on the things that we got hung up on in the networking classes. I want you to be able to go through and configure this thing and understand what goes on with the address and with the subnet mask. How do we actually determine the network address? How do we actually determine the host address? Are you going to be doing that? Yeah, maybe. Subnetting, the subnet mask. The subnet mask tells us how much of the address is network and how much is host. And networks, if they're on the same network, they can communicate. If they're on different networks, we have to have the router in order to be able to do that with us. And their activities, you can go through and look at their activities. Sometimes they're pretty good. You have 3 this week and 2 next week IP exercises to do. If you need help, please ask for help so we can go through those things. The spreadsheet, feel free to use that spreadsheet if you need some of the paper copies of this thing. Some people prefer the paper, some people prefer the spreadsheet. To me, what this does is keeps the ones and the zeros straight so that you know which is where. And it's got the values at the top of it too, so that you can do the addition. The spreadsheet will do the addition for you. I think I went through that one too fast. The A's, the B's, and the C's, this is one wasn't the one that I thought it was. 0 to 255, 255, 255, 0 addresses. Class A, B's, and C's, total number of addresses and number of networks that are available in each of these things. So we have 192.0 to 192.022.255, and how many addresses is that? 256. To give us a total of 254 usable addresses, because we can't use the host address that's all zeros, and we can't use the host address that's all ones. The all zeros host address is the network address, and the all ones host address is the broadcast. That's where the subnet mask comes in. How much of it is host and how much of it is network. All right, let's see. Classless, consider the classless internet domain routing. We need to know the classes. We define the classes so you know where to start with the subnet. What are you subnetting? Because if you don't know where you start, you don't know how many bits to add to these things. How much of it is network and how much of it is host. Supernetting. Supernetting simply means that we are going to group multiple networks as a single addressable network. And one of the examples, although it's not a great example, because when they decided to do the addressing here, they used a 10 to start with, and then we subnetted everything as Class C networks. But if you were doing route tables at Virginia Beach for all of the different locations, and in this building we've got a number of networks, 1062.11 here, 1062.08 in room 108, 1060.61 I think for the faculty, 1060.201, 1060.215. What would make life simpler if we had 15 networks in here and you were at Virginia Beach and golly, you want to put 15 different entries in the route tables? Or do you want to be able to put one? What was common in all of those addresses that I talked about? The 10.60. So if we subnet that so that the network address is 10.60, everything that starts with 10.60, and we use a 255.255 at Virginia Beach, say that's the network address, everything that starts with 10.60 gets sent to Roanoke. When it gets to the Roanoke router, it can then route it to the individual rooms using a 255.255 subnet mask, 24-bit mask. So we use a 16-bit mask to get it here and a 24-bit mask to distribute it once it gets here. And if you'll look at, I think for those of you who have Cox Cable, if you look at Cox Cable, I think they use a 252 subnet mask, or at least in my neighborhood they use a 252. Why? How many hosts do you need in that case? They may have more than 254 subscribers on that particular node. If you need more hosts, we move the subnet mask to the left. If we need more networks, we move the subnet mask to the right. And once you do that, don't try to think it through. Just move it until you get the number of hosts that you need, and that's the mask. And we have the same thing. We have a network address, all zeros in the host, and we have a broadcast address, all ones in the host, regardless of where the subnet mask is. Public and private addresses, you've looked at those, the 10 network, the 192, 168, and the 172.16, right? 172.16 to 172.32. The private addresses. IPv6 is, you know how long I've been saying, it's coming soon. It's going to be coming soon because they have now issued all the IPv4 addresses. NAT kept us in the IPv4 game for a lot of years. There are advantages to IPv6. There are disadvantages to IPv6. The biggest advantage is security. We can make IPv4 security by using IPsec, by porting it to the IPsec. Improved auto configuration, simplified routing. And the simplified routing is the routers kind of figure things out. One of the things that it does do is it checks the path before it sends the information to find out what the maximum transmission unit is to make the transmission more efficient. It has its own built-in security. IPv4 doesn't. One of the disadvantages, I think, from a security standpoint is it doesn't have any NAT. They built it so we don't need NAT. We got 2 to the 128th addresses, and they've got that number in the book. It's a really big number. Never going to need to NAT again. Well, some people want to NAT because they want to hide their internal IP structure. So there are still some changes, discussions going on as to what's actually going to go on with this protocol. It is efficient, 128 bits, 16 bytes in length. You subnet it with the /. There are some rules. They've only issued a very few of the addresses. The devices today, I think all the Cisco routers support IPv6. The Windows machines obviously support IPv6. They'll get an auto configuration, and they're going to discuss the types of addresses that are. The link local address is kind of like the private IP address. It's within this room, basically. Shortening addresses, the leading zeros you can drop, and these are the kinds of things when you take, at least what I've seen on the Network Plus and the Cisco tests and the Microsoft tests, is what does a valid address look like? You don't have to write the leading zeros. If you have a series of zeros, you can represent them with a double colon one time. If you have a series of zeros, some numbers and a series of zeros, you can only use the double colon once, because otherwise it doesn't know how long each of the series of zeros is. Two or more groups can be replaced by the double colon one time. CIDR notation, 1075 colon, and the 5 would have had a 000 as the leading zeros here. AB12, they are hexadecimal numbers. Colon colon means that this ends with all zeros. Since the system can figure out how long this is, it knows how many trailing zeros there are in this address. /48 means that it's got a 48-bit network address. And the network address would be what? What would be the 48 bits? 4, 8, 16. This would be the network address, right? 16, 16, 16 times 3 is 48. So the network address is 1075 colon 5 colon AB12. That makes sense, doesn't it? Because the network address is the one where the host bits are all zeros. The colon colon represents zeros. I keep clicking this thing too quick now. The addresses, link local, unique local, global, multicast, and special addresses. And I think that the unique local, which represent a location, is one of those addresses that comes and goes. And you'll have to look and see if it's come or gone at this point in time. The link local address is like a private IP address. Global address is a routable address. Multicast addresses, and then the special addresses, loop back, those kinds of things are going to be in the special address categories. The loop back address, it's easier to write than 127. This is the only one that's easier to write, I think. It's just colon colon 1 is the loop back address for IPv6. Mapping for IPv4, 6 to 4 addressing, start with 2002. Teredo addresses, and they discuss Teredo addresses in this book. Teredo are Microsoft's 6 to 4 tunneling protocol. 2001. Multicast start with FF0, 0, reserved, 2001. And FE are the link local addresses. And if you look at an IP config on these machines, they're going to have, I think, one that starts with FE. Those are the ones that find, and they find neighbors. They find machines that are on the same network as it is, as they are. It allows more rapid communication, sharing, and those sorts of things. DHCP will do that later on. Allocation of IP addresses, it does more than that, but we'll do that next time when we do DHCP. A PIPA, automatic private IP address, means that your machine is set up to get a DHCP address, and there's no DHCP server that it can contact. You can set these things up for an alternate address. The alternate, what this really is an alternate address. It happens to be a 169.254 address. Alternate configuration, and they talk about these as you have a system or set up so that maybe a laptop, so that you have a static address in one place, maybe a static address at work and a DHCP address at home, or a static address at home and a DHCP address at work. When you take your laptop to the DHCP location, you get the DHCP address. When you take it to the one that doesn't have a DHCP server, you get the alternate, the static that you put in. And again, the alternate, a PIPA is actually an alternate address that's 169.254 that it configures itself. You've done these many times, manually configuring static addresses, static configuration. Pretty simple in the GUI, and once you've done it a couple of times, not all that difficult in the core server either. Manual configuring, and this is one IP that you may want to look at those activities when you do the IP configuration. Automatically configure. Configuration states are stateless and stateful. Stateless is generally what we're going to have with these things, that they automatically generate their address. There is a DHCP for v6. Neighbor discovery is what I was talking about, that the protocol is used for clients for router discovery on a network, so it does discover it. The protocol discovers neighbors. The net shell command is the one that you're going to use to configure the core, because you're not going to have a GUI to configure it with. So the net shell interface IPv6, add address, interface address, net shell interface IPv4. Just use that, and you can use the help screens, and you may want to look at that just to see what's available, what kind of help's available. There are a lot of commands available in the net shell command. The IPv6, and again, I think we talked about this in Cisco, dual layer stack. Windows 8 uses a dual layer architecture, IPv4 and IPv6. IPv6 over IPv4 tunneling, router to router, host to router, router to host, host to host. We create an IPv4 tunnel. What we really do is take an IPv6 address and stick an IPv4 address on it so that it can get routed from one location to the other. The router to router, if we had two routers that only used IPv4 and we had an IPv6 network at each end, we could use a tunnel 6 over 4 that IPv4 would go between the routers, and one goes to the other end. The IPv4 header gets stripped off and it uses IPv6 at those locations. You can use both of them. ISOTAP, routers and hosts to communicate across IPv4 networks. You have to have a router that supports this. This looks really cool. And I said, I'm going to do this at home. My router doesn't support this, obviously. But it has to be supported by the router. The interface, the ID interfaces, the first 32 bits are either 0, 5EFE for a private address, or 200, 5EFE for the public addresses. The last 32 bits are the IPv4 addresses. They incorporate the IPv4 address in a lot of these auto-generated addresses. I guess that actually gives them some form of uniqueness. 6 to 4, tunneling the packets over the IPv4 network. Stores the IPv4 addresses of the ISOTAP router in bits 17 to 48. So the difference between the 6 to 4 and the ISOTAP is where the IPv4 address is stored in the address itself. Which protocol is using, and which protocol, so that the protocol knows to where to look for that particular part of the address. Teredo, IPv6 host to communicate over IPv4, uses a NAT process, and this is something that is built into part of Windows 7 machines, the Server 2008 machines, and I think if you look there, mine at home at least says that it's not connected for the Teredo. You have to have Teredo enabled for these things to work. Net shell to enable, and the commands to enable each of these things on it. Enabling Teredo, show Teredo, and there are a number of show commands, sounds like Cisco now, doesn't it, that allow you to see what's there, because when you get in there, like, what is the network interface's name? Well, golly, I don't know. You can go in and show the names. Which one are you going to configure? Because you can't go to the GUI anymore, no GUIs. for clients, each of those things, and those are just commands, and those commands are in the book. Can disable IPv6 for your network connections by editing the registry. And again, he's got a lab in here. I don't ask you to do it. I think it's easy. You know that you can disable it. I don't know that you really want to disable it even if you're not using it, because there are some things that IPv6 makes networking more efficient for. Troubleshooting, and these are the ones that we've used before. Ipconfig. This is handy when you have a problem with your network, and I try to help you. This is one of the first things I'm going to look at. Ipconfig all. We're going to look at, is the address valid? Is it on the same network that we think we're on? Is the subnet mask right? Is there a default gateway? A lot of times you don't see a default gateway. I can't get anywhere. Well, golly, yeah, because you don't have a default gateway. If it can't find it, if it can't ARP for it, it can't get there. Ping. Been there, done that. The problem with ping today is a number of remote sites don't answer pings. Just because it doesn't answer doesn't necessarily mean that you're not getting there. One of the ones that has continued to answer is Yahoo. Microsoft doesn't answer. Google, I think, does sometimes and sometimes doesn't. You can also look at this thing, and if you're pinging to a fully qualified domain, www.yahoo.com, will tell you whether DNS is working or not, because you'll get the IP address of the destination. So this is one that can check connectivity at layer 3. Doesn't mean that the application is going to work, and also tell you whether DNS is functioning properly for you, or functioning at all for you. Pathping, map the hops of the packet must take to reach the target. And again, if you haven't used this one, take a look at it. Just try something. Pathping to www.yahoo.com does take a little longer. It is kind of a combination of ping and traceroute. Traceroute been around for a long time. The hops, and what this depends upon is that the router doesn't do anything, that the router times out, that you actually exceed the hop count and get an error message back. Take a look at the switches when you do trace route, and if you turn off DNS resolution, it's going to be a whole lot faster than if you leave DNS resolution on. NetStat, displaying the network connections. This is one that's handy. What's connected to you? Do a NetStat. I like to do a NetStat every once in a while just to see what's connected. Say, where did that come from? What's doing that? Is somebody connected to you that you don't know about or don't want to be there? Systematic approach, troubleshooting. This is one that the effective troubleshooting, I think, as you break more stuff, as more things don't work for you, that troubleshooting becomes a more logical approach. What do you use? What do you test first? What's the most likely thing? And then here, what's the most likely thing? That somebody unplugged the NIC, probably. Or on the left-hand side of the room, is somebody plugged in their laptop and shut down the port. So networks are designed to allow us to communicate, routers to allow networks to communicate with each other. IPv4 is the U.S. industry standards. There are some places that have, parts of the world that have gone to IPv6 simply because they didn't have any IP addresses. You've looked at the IPv4 addresses before. The IPv6 looks a little different. And to me, they're a little bit harder, not a little bit harder, they're a lot harder to type because they're hexadecimal. We're used to the 192.168. Well, what's the 192.168 in hex? Those kinds of deals. It's going to be different when we actually get to it. It's going to be more efficient. There are still some changes, I think, that are being made as they go through the address. Private addressing. Private address is something that shouldn't be needed in IPv6. It is one of the things that's kept us in business in IPv4 between private addresses and Pat. Are there questions? Get done so you can do the lab.